Okay, so now let's look at number 4, find the value of z. But now let's use what we learned up here on the cosine, sine, and tangent. So the value of z, now I'm going to look at, I used 50 in the previous problem, so now let's look at 40 degrees so you understand that you can use either or. But what we have to first understand is what's given to us. Well, with 40 degrees, the opposite side is given to us, and we're looking for the hypotenuse. So you always want to pay attention to that information, because now we know this is the ratio we want to work with. So if you come up here, opposite over hypotenuse is going to be the sine. Okay, so that's the same thing as sine. So we have sine of 40 degrees, which is equal to opposite, so my opposite side is 3, over my hypotenuse side, which is z. And so remember, when we're dividing by the variable, flip-flop here. So I have z equals 3 over sine 40 degrees. Okay, and then I'm going to go to my calculator. Go to my calculator here, which, let me clear this so we can go over it. Just real quick, make sure that you have your degrees. Okay. So you want to do 3 divided by, click your sine 40 degrees. Enter. So now we get the exact same thing we did in our previous question, 4.66. So let's round it. So z again is 4.7. So now you see how you can use the calculator to find these, and they don't have to always be just the tens in our estimate. Now we can actually find the number. Okay, so I did number 1 for you all on this one to help you all out over here. So we're looking for the hypotenuse. Since I know the adjacent side is 10 here, and we're looking for the hypotenuse, so I want the adjacent over hypotenuse, which, remember, if you go up here, adjacent over hypotenuse is going to be cosine. Okay, so that's how I set this up here. My adjacent side is 10 over my hypotenuse, which is going to equal cosine 17, and we're going to solve for h. So again, I just flip-flop here and here, and so I get h is equal to 10.5 units. Oops, I should have put units up here too. Okay, and if you did the live video with me on that Friday, I gave you a thing, it's called SOHCAHTOA. And what that means is to help you with your trig functions here. So it's so, like this, but here's how you want to write it out. Ka. Okay, so, and then toa. So what this means is your sine is your opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's just a real quick, even when I'm teaching the ACT prep course in the summer times, and I have a trig question come up, in my head I'm like, SOHCAHTOA, and I write this out immediately. But this is how it translates to the ratios. It's an easy way to remember which one goes with opposite, which ones go with adjacent, in the order. So this is almost a must to memorize because it makes life just a whole lot easier. So let's look here at number 2. We're searching for y, so what we have to understand, we know this is our 90 degree. So if we know which one our 90 degree is, that means we're given our hypotenuse. If you're given the hypotenuse, then you can use either sine or cosine. I'm going to write these over here. I think this helped the other day. So we know we can use this one or this one because we know the hypotenuse. But then the question is, which angle do you want to use? And it doesn't matter. Just pick one, go with it. Don't go back and forth. So I'm going to look at 48 degrees. If I do 48 degrees, then I know I have my opposite side. So that would be this one. So now I'm going to be using sine of 48 degrees is equal to my opposite side, which is y, over my hypotenuse side, which is 7. Okay, multiply both sides by 7. And then type that in your calculator. So let's see here. 48 sine times 7, 5.20 units. Okay. So I hope you guys understand where the ratio is coming from, and I hope that that makes sense how I set that up. Hold on, I'm pulling something up real quick on my computer. But write this down each time if you need to. Okay, or I'm going to leave it kind of posted for these next couple of questions so we can kind of look and use it as a checklist. So, find all the missing sides and angle measurements. So on this one, it's actually wanting everything. So let's first draw a triangle. We know every triangle we're working with right now is a right degree, or right angle. So this is going to be x. Our y is going to be 12 degrees. So let's call this y. So that would mean z is up here. What else do we know? We know that xz is 2 centimeters. Okay, so we have several different things that we need to find right now. Stick with the first thing. I always find it easier, this is just me personally, leave the angle as the very last thing to find, because then you're not getting confused at which angle do I want to use or which angle did I use, and so on. So if you are using, let's see, we're using 12 degrees here. So we're using 12 degrees here, so that means I have my opposite side. Now, it doesn't matter which direction you go there. I'm going to go ahead and search for my hypotenuse. So I want opposite over hypotenuse. So I go up here, opposite over hypotenuse. I'm going to use my sine again. So if you make these little notes, everything right there is set up for you. My sine of 12 degrees is equal to, my opposite side is 2, my hypotenuse is 8. That's what we're searching for. So to find 8, I have 2 divided by sine 12. Okay, let's type that in the calculator. Okay, let's type that in. Remember, we're trying to find the hypotenuse side, which is yz, so you should get 9.6 or centimeters. Okay, so now we still have this side to find. So again, we only have the 12 degrees. So now I know I want my adjacent side. So, and again, you have too much information, so you have to kind of pick and choose. I know I want adjacent. So remember, adjacent's here and here. So you can use either or of these. If I'm searching for something, I'm really trying not to pick it in the denominator. I'm going to choose cosine. So I'm going to do adjacent over hypotenuse. Okay, which is going to be my cosine. Alright, so if I have cosine now of 12. My adjacent is what we're looking for, but I know my hypotenuse is 9.6. So I'm going to multiply both sides by 9.6. And then type that in the calculator. So I have cosine 12. If you're using your phone calculators, take care of your trig functions first. So type in 12, then hit cosine, and then multiply that by 9.6. So hopefully you came up with about 9.4. So my adjacent side is going to be 9.4 centimeters. Now you can do a quick check here. Also, you know that your hypotenuse is always going to be your longest side. So double check, even though it's just barely longer, it is longer than our other two sides. So just a quick double check. All right, so I found all my sides. So now I just need to find my other angle. Okay, remember that you can either do it by everything adds up to be 90 or 180, or you already know this is 90, so the other two have to be complementary. So if you just did 90 minus 12, then you get your other angle to be 78. I'm going to change colors so you can kind of see. So 78 degrees. Yeah, so there's everything that we found on that one. Okay, we're going to be doing the same thing with part B. All right, part B. I'm going to erase some of this over here so I have a little bit more room. Maybe. Okay, so now again, we have our 60 degree and 4. Now, this is 1. If you know 60, then you know this is 30. So we have a 30, 60, 90. So this triangle follows the x square root 3 ratio and 2x. This is our short side, so that's our x. So we have everything else. Then we know our long side is 4 square root 3. And then we know our other side is double this, so 4 times 2 is 8. You have everything you need right here. And you can type this in the calculator and get a decimal if you want to, or just leave it as 4 square root 3. So if you can pick up on these 30, 60, 90s and 45, 45, 90s, your life will be so much easier at finding these sides. All right, so let's look at part C now. Again, draw yourself a picture. This is my 90 degrees, so this is going to be K. L is 71 degrees. And LM is 20 degrees. All right, so again, So again, I know my hypotenuse, and I know 71. So I know I'm going to be using either sine or cosine, because I know my hypotenuse here and here. Okay, it doesn't matter which one, so let's look at this one first. So I'm looking at this side. Actually, let me do my letters. This is going to be my adjacent side. So I'm going to be looking at adjacent over hypotenuse, which is cosine. And you don't have to write this out every time. I'm just using this as a notes so y'all understand where everything's coming from. So cosine and my angle is equal to my adjacent side is A. I don't know that one yet, but my hypotenuse is 20. So multiply both sides by 20. So therefore I get A is equal to, and I don't have these previously worked out, so let me type it up. Let's see, I get 6.5. And we're talking about centimeters. So I know that this side right here is 6.5. Okay, so now I'm going to still use 71, but now I'm going to go to the other side. I'm going to go over here. So now I'm going to be searching for the opposite side this time. I'm still going to keep my hypotenuse. So now I'm going to look at sine. So now what I'm going to be doing is sine, which is my opposite over hypotenuse. Okay. So with knowing that, I have my angle. So sine of 71 is equal to my opposite side, which I don't know yet. So that's going to be, I'm going to put an X so because the O looks like a 0 sometimes, over 20. Again, multiply both sides by 20 to get my opposite side, which will be 18.910, so I'm going to do 18.9 centimeters. So this opposite side over here is going to be 18.9. Again, my hypotenuse is still my longest side, so we're good there. And then we have left to find the angle, which 90 minus 71 is going to give us 19 degrees. So let me kind of sum this up for you. So my angle, M, is 19 degrees. KM, segment, we found to be 18.9 centimeters. And then KL is 6.5 centimeters. Okay, hopefully this is helping you all. This one, literally, all you had to do was type it in the calculator. I'm not going to go through that one because that one's not quite as important. So, if you have any questions on this still and you're not understanding, please email me. I'm hoping this really is what you wanted to get out of this lesson. Okay, and obviously you weren't really supposed to come up with that on your own going through it. You were just supposed to kind of see that these columns turn into sine, cosine, tangent, which is just a calculator because they're set ratios. All right, again, if you have questions, let me know. Otherwise, I'm going to go on to the next video.